In this lesson, we're going to use proportions to solve for an unknown value. All right, question number 1 says Shauna reduced the size of the rectangle to a height of 2 inches. What is the new width if it was originally 24 inches wide and 12 inches tall? All right, Shauna reduced the size of a rectangle to a height of 2 inches. What is the new width if it was originally 24 inches wide and 12 inches tall? All right, so let's start with our original. Let's just draw this out so we can kind of understand what's happening here. So we're taking this rectangle and we had it 24 inches wide and 12 inches tall. All right, so it's saying that the height of the reduced rectangle is now 2 inches. So now what we need to do is we need to ask ourselves, because if we don't keep it proportionate when we reduce it, then it doesn't keep it same size, or same shape, I should say. And so let's take a look. You could set this up as a ratio of the 12 inches all over 24 inches is equal to then the height of 2 inches all over x inches. Sometimes in this case, let's just take a look. How do we go from 12 inches to 2 inches? Well, it appears that we divided by 6. So in this case then, for the width, I would also have to divide by 6 here. And then that means that this was then 4 inches wide when you reduced it. All right, in our next example, it says the ratio of boys to girls is 3 to 2. If there are 12 boys, how many girls are there? All right, well, let's go ahead and let's start our ratio of boys to girls. So we'd have 3 boys to every 2 girls. Now it wants to know if there are 12 boys, how many girls are there? So we're going to line up our boys. So there's 12 boys. Then we need to know, well, we don't know how many girls. So we could either look at this as that we could say, well, I'm taking 3 times 4. You could say, well, how did I go from 3 to 12? I multiplied by 4. If I did that on the top, I could do that then on the bottom. And that means that I'd have 8 girls. Now, you could certainly cross multiply and divide as well. I just think in some of these, it's just easier for you to look at the relationship between the new ones and then do it that way. All right, question number 3. It says, it takes 1 supergiant pizza to feed 3 people. If you've invited 36 people, how many pizzas will you need? Well, let's make this a ratio. So it takes 1 supergiant pizza. So for 1 pizza, for every 3 people. Well, if you invite over 36 people, we need to know then how many pizzas you need. So we know that 3 times 12 is equal to 36, so you could do it that way. Or we could cross multiply and divide, which ends up being the same thing. 3x is equal to 36. You divide by the 3. And so that means that you'd have 12 pizzas. So if 3 people per 1 pizza, if you have 36 people, you need to have then 12 pizzas. All right, question number 4. At a recent party, it cost $9.50 for refreshments for guests. At this rate, how much would it cost to have refreshments for 80 guests? All right, so, well, if it costs $9.50 for every 10 guests, we now need to know then, all right, well, how much would it then cost, not for 10 guests, but for 80 guests? All right, so let's go ahead. Let's cross multiply and divide. So I'm going to take 10 times 5x, and then we'll take 80 times 950, and you get 760. And now we just need to continue isolating the variable by dividing by 10. So it would be $76 it would cost then for 80 guests. All right, question number 5. Mary has saved $17.50 in the past 3 weeks. At this rate, how much will she have saved in 15 weeks? All right, I'd like for you to pause the video and for you to set this one up and solve it. And then let's resume the video and check your answer. All right, so I set this up as $17.50 for every 3 weeks. And I didn't want to know for 3 weeks, I wanted to know for 15 weeks. So certainly I could cross multiply and divide, but I saw that to go from 3 weeks to 15 weeks that I multiplied by 5. So if I did that on the bottom, I'd have to do it on the top. And so that means that for 15 weeks, it is going to cost $87.50. All right, question number 7. It says, Jack was planting a tree. He was to dig a hole that was 3 feet deep for every 5 feet of the tree's height. How deep should he dig the hole for a tree that is 17 feet high? All right, so he has to dig a hole that's 3 feet for every, and that's the hole. So I'm going to label these with the hole and then for the tree because they're both in feet. How deep should he dig the hole? So, and this is for every 5 feet of the tree height. All right, so if he has a tree that is 17 feet high, we need to make sure that we put the 17 feet tree on the bottom. And then we're looking then to see how deep of a hole that he's going to need. All right, so I'm going to cross multiply and divide. So I'll take 5x is equal to, all right, 17 times 3. And you get 51. All right, now let's just isolate the variable. And you should get then a hole that is 10.2 feet deep if you have a 17-foot tree. All right, our last one here. It says a certain shade of green paint is made from 5 parts yellow mixed with 3 parts blue. If 2 cans of yellow are used, how many cans of blue should be used? All right, well, so let's take a look here. So you have 5 parts yellow. Is mixed with 3 parts blue. If 2 cans of yellow are used, how many cans of blue should be used? All right, so now we need to line up then our 2 cans of yellow. So I'm going to have the 2 cans. And in this case, we're making sure that we're lining up the yellow, even though we've got parts and we've got cans. So as long as the yellows are lined up now we can solve for our blue then, how many cans. So let's go ahead and we're going to then solve 5x is equal to then 6. And so now I'm going to divide by 5. And 6 divided by 5, then you're going to have 1.2. So that means that you'd have 1.2 cans of blue paint. In this lesson, we took a look at how to find the unknown value in proportion problems.